Okay, some more Minesweeper. I know it's been a bit, but I thought do some more Minesweeper. Not sure where I left off. Okay, haven't done this before. I mean, haven't done most of this, so let's see. Liar. Each clue is either one greater or one less than the actual value. Okay, okay, got this. So we have a 0, but that could be a 1. I assume, it can't be like a negative 1. Okay, 5. Well, clearly then this is a 4. 1 is either a 0 or 2. This is either... okay, it can't be a 2, because if it was a 2, then this would have 2, and this has to be a 1, so this has to be a 0. Either one of these is a mine, or both of these. Or either none of them is a mine, because of the nature. So this is either 0 or 2, which means either neither of these are mines, or both of these are mines, which then would mean that this one isn't a mine. Okay, that has to be that. Okay. So this is either 3, in which case it's done, or it's a 5. But if it's a 5, then this 0 would be a 2, so it's not done. You have 4 mines remaining. Okay, so this 3 has to be a 4. In which case, this 1 would be a 2. This is not a mine. That's that. There we go. Next level. 6, 5. Okay, so this is either 2 or 4. If it's a 4, both of these are mine. In which case, this 0 would have too many mines. Therefore, not be mines. 4 is done. One of these has to be a mine. Therefore, the 2 can't be a 3. That's not a mine. Ah, okay, so this is done because this is either 2, in which case it's done, or it's a 4. And if it was a 4, 2 of these would be a mine. Or I guess if 2 of these could be a mine, then that. Yeah, this could of course be a 2. This cannot be a 4 though, because if this is a 4, way too many mines. So this is a 2, which then also means that this has to be a 4, because at least one of the mines would have to be here. And because this is a 4, there has to be 2 mines here. That's not a mine. Okay. I realize when I'm pondering, I should, talk more, right? Engage more. But, I'm just pondering what's the next step. It feels though this has to be the area that we advance in. So, like this 0, it's either, well, this 0 has to be a 1. If it was up here, then there wouldn't be enough because this we know is a 2. So therefore, okay, so both of these have to, okay. One has to be a 0. That's that. That's that. That's done. That's done. Okay, so this 0 sees 1 mine. This 3 has to see another. Either this 1 sees no mines. This 2 could still be a 3 with that, or it sees 2 mines, and then there's, 1 more mine, however it is. Oh, the 4 is done. Done. 0 is done. Okay, so either these 2 aren't mines, or they are both mines. Um, In either case, this 3 would be complete. So this, because of this 3, either neither of these are mines or both of these are mines. In either case, then this 3 would also be done. Well, actually, if it's neither of these two are mines, it still could be that these two are mines. Yeah, mine. So I'm glad I didn't rush to that. Let's see, we got this one, this one. Okay, so the 2 could just mean 1. And let's say, for example, this 1 is a 0, and then this 2 is like 1. This 2 could still be... If this 2 is a 3, it'd have to be a mine here. Let me do some drawing. Let's imagine this 2 is a 3, we would have a mine here, mine here, mine here, because we couldn't have an extra mine in this area. In these areas, we couldn't have an extra mine. So we have to have a mine here, and then we have a mine in either of these two spaces. By the nature of the 1, we would have to have a mine here. And then these wouldn't be mines, that would be a mine. And then one of these two would be a mine. This would be a mine. Entirely feasible. Entirely feasible, which doesn't help. I need stuff that isn't feasible to make my deductions. So these three are sort of interlocked. I mean, they're not fully, because it could be like this. Because we just looked at that path. So, and I feel as though it has to be something like, a binary, something that can either be one way or another way, like how the 1 is either both of these are mines or neither of them are mines. But I feel as though it has to be something related to something like that. If neither of these are mines, it could be... Okay, if neither of these are mines, right? Let's run with that assumption. Now we're going to make another assumption that this 2 is a 3, in which case all these are mines. In which case, because of this 2, we would have a mine. We would have to have these 2 be mines. Well, I know where I'm going with this, but if neither of these are mines, if this is a 0, right, then these, and we assume then that this is a 3, so we make 2 assumptions. This doesn't work because this 3 would need 1 more mine, but there's no way that could be because this 2 can't actually be a 2. So one of these 2 assumptions has to be wrong. So now we take the assumption that the 2 is a 1. Let's see where that takes me. Even if we assume the 2 is a 1, actually I don't even think I need to do this. Okay. If this is a 0, this 2 is either a 3, in which case it doesn't work, or it's a 1, in which case it also still doesn't work. Right? There's no way for it to work, because then this 3 is a 3, and we know these numbers align. Therefore, this 1 is a 2. I'm very thankful that issue. Okay. Now we know, sort of from deduction earlier, that the only place we could have in mind is for this 3 is there, because if it's down here, it wouldn't make any sense. That's done. There's 2 mines remaining. We know this 2 has to have 1 more mine in one of these spaces. And then because of that, there has to be a mine here. So I'll just... Okay, there we go. I'm gonna go until I have about 5 of these done. That should be a nice one. I think we've been doing 5 on these videos. Let me know if you think they're too long or if they're too short. Speaking of shorts, I think I might do some shorts. Shorts seem to be really popular nowadays. I think that popularity, I mean, granted, um, doesn't mean I have to do short, but I think maybe I try them out. See where they go. Okay, so this 3 is going to be a 2. This 0 is going to, this 0 has to be a 1, right? Zeros have to be a 1, so then, like that. 5, that's a big number, and it's clearly not a 6, so this is really a 4. Because it's not 6 spaces. But this 4 has to be a 3. We already know one of the mine's there, so that's that. And there's no way for it to go, I think one, well, this 2 could still be a 1 if it's like that. That. What if we had a mine here, mine here? We could have that. It's also still entirely feasible. So that's option A, and then option B is the option where it's like that. So any option where this isn't a mine, like what if this isn't a mine? It would have to be like that, and then, okay, so that has to be a mine. And either both of these are a mine, and this is a 3, or none of them are mines. And if none of them are, if neither of these two are mine, there is not enough for this 4, therefore. Okay, this will be, I think, the last one. So let's try to finish this video off on a good note. We is right off the bat done. So if this is a 0, it's already done, and if it's a 2, then there's a mine in one of these two spaces. So either there's a mine in one of these two, and this 0, 1 is done, or there's a mine in one of these two, and neither of those are mine. Those are the exclusive options. This 5. I bet you my next step will result from this 5. 5 has to have at least 2 more mines. Okay, my next step might not actually come from this 5. This 4. Let's assume the 4 is like a 3. Something like that. It could just be something like that, right? There's a lot of different possibilities at the current state. Bit obvious. Okay, this cannot be a mine. Actually, neither of these two can be a mine, because if these two are mine, yeah, this one has to be a 2. I don't know what I was thinking earlier. This one has to be a 2. Therefore, those aren't mine. That's that. That's that. That could be a 4. Would do. Okay, so one of these is a mine for the 3, and 3 is a 2 in this case. Then this 2 would have to be a 3, so one of these would be a mine. This 3 is either done, or it's double mines. Okay. If the 3 is done, if this is a 2, if this 3 is a 2, these aren't mines, and this 5 is impossible to complete. Therefore, actually, both of those have to be mines. Now done. 2 can only be finished like that. On a mine. Okay. Could be a mine there. A mine there. There's not a lot of numbers. You would think it'd be easy if there's not a lot of numbers. Could be a mine there and a mine there. Okay, those are... So option A, there's a mine here. That finishes out the 2, finishes out these 3s. And therefore, there has to be a mine here. Alternatively, you have a mine here. That finishes out this 2. And you could still have something like this. Or like this. There's 4 mines remaining. So with this we could definitely have 4. In the other one... Okay, so if this was a mine, then this is not a mine. Yeah, I'll actually do circle for mine. That's a mine. Not a mine. Then this 3 would have to be done. And there's not enough spaces for mines. Therefore, that is not a mine. You have to fit 3 mines left. Let's say if there was a mine here, 3 would be done, and so the 4, not enough space for mines. Not a mine. Go. And with that, we also unlocked a new category. Can explore that in a future video. But thank you for watching. This has been Minesweeper Variants, and hopefully I make more of this if you enjoy it. See you later.